How many pieces of evidence do you need to say that? You should be sure. Side, side, side. How many pieces of evidence do you need? Just to answer my simple question, how many pieces of evidence do you need to say side, side, side?
No,
So do you have all three? I'm not saying they are. I'm just asking you. Okay. So before we get to the actual proof, let's get some different types of input. Let's start with what final postulate, theorem, property, definition you thought of using to prove it. What did you want to use to say that they were congruent? Dalton? Side angle side. Well, we're learning side angle side today, so does that mean that you already know it? Okay, so you wanted to use side angle side. Ania? Side, side, side. Chris? Side, side, side. So how many pieces of evidence do you need to say side, side, side? How many actual pieces of evidence? Tristan? You need 3 actual pieces of evidence. So if you use side, 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 look on your proof. Do you have 3 pieces of evidence before saying side, side, side congruence postulate? If you have 3 pieces of evidence, then there's a good chance you got it right. Now let's back up. What's the path or chain of logic? If you're going to use side, 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 that means that you want to prove that congruent to that, you want to prove that congruent to that, and you want to prove this congruent to itself. So if you can do that, if you can show those 3 things, then you've done your job. So, last way of looking at it. How many steps did it take? How many statements are in your proof? Zabari, how many statements are in your proof?
5.
Dalton, how many are in yours? 4. Anyone have something different? How many are in yours? 4. Okay, so here is my proof, and it does not mean that mine is the only way. It means that it is one efficient way of doing it. So I started out by using one of the given. Here's why I think you have to have at least 5 steps. You can't just say that and then say that these two are congruent to each other. You then have to say that they're congruent to each other because of the definition of a segment bisector. So if you have 4 steps, I'm wondering in my mind if maybe you skipped over that. If you did, that's okay. It doesn't make you a bad person, but it's something that we need to learn from. So that's my first piece of evidence. I just showed that this is congruent to this. So one piece of evidence done. So then I kept going. DC is congruent to DE. That is also given. So this is congruent to this. Second piece of evidence, done. Someone tell me, how do we prove the third piece of evidence? What's the special idea, property, whatever? Brandon? DF is congruent to DF because of the reflexive property of congruence. So this is congruent to itself, my third piece of evidence. And then the last statement, of course, is the prove statement. They are congruent because of the side-side-side congruence postulate. Okay? This is in no way the only way to do it. But pretty efficient. You could have changed the ordering. If you have this, the bisector, and this is down here, and you put this part up there, that's no different. Because all 3 pieces of evidence are independent of each other. Okay, so let's go around. Sebastian, Brandon, Brian, and then Dalton, and then over here. Go.
Instead of saying definition of segment bisector, could you say definition of
Well, you skipped over something. Remember that your proof has to be something that an idiot can read and understand. Where did you say midpoint? Did you say that because this bisects this, that makes point F the midpoint of that? And then say that because it's a midpoint that they're congruent? So you skipped over a step of logic. Your logic is fine, but you skipped over a detail. Okay? Do you understand? At no point in your list of statements did you establish that this was the midpoint. If you did establish it, great. So did you establish it? Okay. So now, next time, use the idea, but you have to write it down. Okay? Brandon.
Is it okay if you group the digits together in one statement?
Yes. It seems to be kind of dependent on who's reading it. Seems like the publisher does it all the time. Remember, I'm learning along with you, so I'm totally fine if you group the givens all in one statement, as long as it's not like 5 different things all grouped together. It gets a little hard to read, but for the most part, I'm fine with it. Brian? I'm sorry? Never mind. Okay. Dalton?
I use the two givens, and then I use the reflexive property, and then I use the side.
Okay. But side angle side requires 3 pieces of evidence. A side, another side, and then an angle that's inclusive, meaning in between. So what angle did you use? So that's the flaw in your process, is that if you wanted to say this side is congruent to this is congruent to itself, and then you wanted to say this was congruent to that, then you could use side angle side, but you would have to prove that these were congruent first. So you missed a piece of evidence, your case fell apart, the judge banged the gavel and threw out the case. Now you have to go back to the district attorney and explain why you lost your case. He or she's not going to be too happy. Okay, so, but I'm glad you brought it up, and you're going to learn more about side angle side today. Does anyone have any comments or questions on today's warm-up? So now look at the rubric. Give yourself a score based on the rubric. You have the rubric in your notebook as well. You don't need to look over here. Sounds like many of you should be in the score of 3 or 4. You know, if you skipped over step number 2, that's a major omission, so it might drop you down to a 3. But other than that, most of you seem to be in the 3 or 4 range. Any comments, questions, any concerns, any issues? Okay, so of course you already titled today's lesson, lesson 4.5, and today we're going to add to our toolbox. If you've noticed, that's what we've been doing most of the chapters, is building this toolbox of knowledge and properties and theorems and postulates that allow us to prove things. And so we're going to add to that today. We're going to add to it by adding in side angle side and hypotenuse leg. So those are our objectives today, to learn how to apply these to constructing triangles and solving problems, and to prove triangles congruent by using side angle side and hypotenuse leg. You'll start seeing the phrases included angle and included side over the next couple of days. So, you have this on your cheat sheet, which should be out already. But side angle side congruence postulate functions very similarly to the side side side. If you want to prove 2 triangles congruent, you can say that if 2 sides are congruent to each other, and then another 2 sides are congruent to each other, and then the inclusive angle is congruent to each other, then you may use side angle side to prove them congruent. And so, you have to really the only detail to pay extra close attention to is this idea of the included angle, which means that the angle must be the angle that's connecting the two congruent sides. So look at it this way. We did an experiment last week, and in essence, this is what we proved. If you can show that, then that automatically means that the triangles are congruent to each other. So the third side doesn't matter. What matters is the two sides with the angle that's connecting them. Any questions about that? Then we have the hypotenuse leg congruence theorem. And it's a theorem because it's supposed to be proven. We're going to start using it right away, but at some point you're going to have to prove it. And this one's a little bit different. What's the first thing that jumps out at you with hypotenuse leg? Fung? Yeah, this applies to right triangles only. So you have to be careful, because now if you want to use hypotenuse leg, there are still three pieces of evidence. Here's what I want you to be aware of. Side, 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 which you already know. Side, 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 three letters, 1, 2, 3, three pieces of evidence. Side, angle, side, three letters, three pieces of evidence. And so then you might look at hypotenuse leg and say to yourself, oh, well, based on that pattern, hypotenuse leg only has two letters, I only need two pieces of evidence. But that's not the case. You still need three pieces of evidence. You need the hypotenuses congruent to each other. You need a leg congruent to each other. What's the third piece of evidence? Maria? That they're both right triangles. So you still need three pieces of evidence. So in terms of writing a proof, all three pieces of evidence have to be written down. Okay? Any questions about either of the new postulate or theorem that you're learning today? Comments or concerns? Okay, so we're going to jump right in. Example 1, we're going to use side angle side. We're going to do a couple of different problems, but we're going to start with a formal proof. So, we're going to write a proof and we're going to work together. But I want to give you an opportunity to try and figure out a chain or path of logic. So we're going to start together about this chain or path of logic. And keep in mind, we're trying to use side angle side. So we're focusing in on that. So we need the three pieces of evidence. Okay? So we're not writing anything down yet. We're talking about logic. We look at the given, and it says BC is congruent to DA. One piece of evidence. Done. Can someone see another piece of evidence that's already not given to us, but fairly simple? Something you've seen a lot recently. Alicia? By what? Very good, you said that beautifully. That's congruent to itself. So we now have this side congruent to this one, and this congruent to itself. So now we need to show this is congruent to that. If we can show that, then we've got side angle side. But I don't know how to do that. The other stuff was pretty clear. This was given to us right there, and we're getting very used to the reflexive property, so we've been doing that a lot. So now I don't know how to get that angle. So you're going to have a minute of team talk to see if you guys can come up with a strategy. Remember, we're not talking about the proof yet, we're talking about logic. Team talk, and see what strategy you can come up with to get those angles congruent to each other.
You know, like chapter 3 or whatever, you know, that 2 lines in the transversal chain and one is to 8 and stuff. I guess line 8 is transversal.
Okay, so let's see what we came up with. And remember, we are trying to figure out a way to show this. Trying to figure out a way to show that. So what'd you come up with? All right, we'll start with Fung, and then we'll go to Jada. What'd you come up with? Alternate interior angles. Okay, well, all right. We'll come back to that in a second, Jada. It's the same thing. Well, what made you think that? How do you know that they're parallel? Oh, it's right there. It's given. So it says BC is parallel to DA, which makes this line right here, what is that now called? It has a name. What is the name? That's a transversal. So for those of you who didn't see it, and still maybe don't, what if I did this? Took that away, and took that away. Now the picture should look much more familiar. In fact, I could take it a step further, and if I made the picture look like this, going all the way like that, that might make it even more convincing. So yeah, they were absolutely right. Those 2 angles are alternate interior angles. By the alternate interior angles theorem, congruence theorem, they are congruent to each other. So now we have our 3 pieces of evidence. 3 pieces of evidence, our final statement, triangle ABC is congruent to triangle CDA by side, angle, side, congruence postulate. Okay? So let's build the proof. So you guys can go ahead and start working on your own. We can work simultaneously. And we'll follow Brandon's idea of just grouping the given all together. So start out with BC being congruent to DA. And that they're also parallel to each other. And that's given. Any comments, concerns? You already finished it?
No, I can't see the picture.
Oh, sorry. Let me bring the picture back up. Could have sketched the picture for yourself. Remember, something like this doesn't need to be a perfect replica of it. So now just start laying out the evidence, right? You're in the courtroom. You're trying to prove the guilt. You have to lay out your evidence. So start with something simple. We already laid out. 1 piece of evidence is done. Second piece of evidence. Let's go back to Alicia. You said that
CA is congruent
That's right. So you can say AC or CA, doesn't really matter. Is congruent to itself because of the reflexive property of congruence. Two pieces of evidence down. Third piece of evidence needed was the angles. So let's go back to Feng. Feng, how would you write it out?
Angle BCA.
Angle BCAA congruent to angle BCA is congruent to BCA. You have to match the order. So BCA, what would have to come first in the other angle? D has to come first because D matches the B. So DAC. And it's hard. I've told you several times already. I have to pause and kind of think about it. But that was, that's just details. We got the major idea, and that's true because of the alternate interior angles congruence. Was it a postulate, a theorem? I don't even remember.
Yeah.
Alternate interior angles congruence. I'm fine with just leaving it at that. Third piece of evidence, done. First piece of evidence, second piece of evidence, third. In fact, you could go as far as labeling them. This proves one side. This proves the other side. That proves the angle. And it's the included angle. So that's side, angle, side. And so we have done our job. We can now put the final proof statement that the two triangles are congruent, and now you're just copying the proof statement itself. Triangle ABC is congruent to triangle CDA because of the side, angle, side, congruence, postulate. Does anyone have any questions or concerns, or comments, or anything about the process we went through? Anything at all? Okay, so example 1b. I'm going to shift gears a little bit. So I'm asking a different style of question. I'm not asking you for a proof. But we have a bit of a more complex picture, and I've introduced a shape that we haven't really talked about yet, the circle. So in this diagram, QS and RP pass through the center M of the circle. What can you conclude about triangle MRS and triangle MPQ? And I'm sorry, my toolbar is covering the P. That's the P over there. So what can we conclude about the two triangles? So I'm going to give you, I guess, another minute team talk to see. And remember, we're trying to demonstrate something focusing on side angle side. So is there something about side angle side that can tell us something about these two triangles? Take a minute to discuss.
And SM is congruent to MQ and RM is congruent to MP, just and the angles are so side angle side. Congruency R M and M.
Yeah, okay, good.
Yes. Because M is the midpoint of everything.
Okay.
And Q M R P is equal to S M R because of both angles.
Okay.
Reversal goes through what? It's hard to tell. All right. So, were you and your team able to conclude anything at all? Let's see what you were able to conclude. Start with Zabari, Chris, Brian. What did you and your team conclude?
Triangles are
You say that they're congruent. Okay. You can prove why. Okay. Give me a thumbs up if you also think that the triangles are congruent. Keep your thumb up if you can prove it. Okay. So that's fair, and I appreciate your honesty. Some of you are kind of like, maybe. So put your thumbs down. So Chris, right off the bat, he said they're congruent and he can prove it. Chris, give me one piece of evidence that proves it.
Angle SMR is congruent to angle QMR because QMR is the vertical angles congruent there.
Very, very good. Right here is congruent to here because they are vertical angles, and vertical angles congruence theorem says that they are congruent. It's one piece of evidence. Now, if we want to use side angle side, that means that we have to show that this is congruent to this, and we have to show that that is congruent to that. So let's see if we were able to figure that out. Anyone able to figure anything out about those lines? So back to Zabari and then back to Brian. Give me another piece of evidence.
M is the midpoint of lines S, Q, and RP.
That's true.
So because the definition of midpoint segments SM and MQ are congruent and also RM and P.
Okay, but let me back up. How do you know that it's a midpoint? It doesn't say it.
It's the center of the circle.
So what?
M is the center of life.
Okay, I appreciate you becoming very grand with your thoughts, but if that's the center of the circle, what if the lines, what if this went like this? That would still be the center of the circle, right? So the fact that it's the center of the circle doesn't automatically say that it's the midpoint of the line. There's something else that helps. So that's the part that we need. Do you want to add on to your statement before I go to somebody else? Okay, Brian was next, and Brandon?
Okay, M is the center of the circle, and both RP and SQ are the diameter of the circle. And since M is the middle, and since they're in the middle, each side is the radius, and the radius is equal.
That's right. And so you had to have, and I'll be honest with you, I threw this in. We have not talked about circles, but I did make an assumption that you had some basic knowledge of circles. And several basic ideas. One, that the center of a circle is important. That a line going from one side of the circle through the center to the other side was called a diameter. But even more important was this fact that he pointed out, which was that this is a radius. And then this is a radius as well. And no matter what, all radii of a circle are by default congruent to each other because they all represent the same distance. They all represent the distance from the center to the edge. So in fact, that's a radius, and that's a radius. And so can someone now make a statement about all 4 blue lines that I just drew? Brandon?
They're all congruent.
They're all congruent to each other. So we can actually go a step further and say this. That's congruent to that, and also congruent to that, and that. And because they're all congruent, we have now shown side, angle, side. And so we can absolutely conclude that the 2 triangles are congruent. Triangle MRS is absolutely congruent to triangle MPQ. Brandon, go ahead. You had been waiting prior to that as
How
well.
would you spell
I'm sorry?
How would you spell
Radii, R-A-D-I-I.
So, would we have to like
No. If you're asked a question in this form, if you're asked to just provide a conclusion and make sure you can support it with evidence. It's not supposed to be a guessing game. It's supposed to be, yeah, tell me what you can conclude. If you want to say they're definitely not congruent triangles, you can have to be able to support why you say that they're not. This is not a formal proof. If you're asked to do a proof, it will say, write a proof. Okay? Any questions about that? Good. So now you've got side, angle, side. Let's see how you do on your own writing a proof, and we are trying to use side, angle, side, even though it doesn't say that. You can use any of the tools in your toolbox at this point. So I'm going to give you 5 minutes on the clock. You may, of course, discuss anything with me. You may discuss with a teammate, anything that you would like. Keep that thought in your mind of the evidence that you're trying to gather. How many pieces of evidence do you need?
I don't know. Right? That's a good question. I like that.
You don't need to do that. Because QP by 6 angle or Q pass and RQP is too good to us. Because the given by 6 and then the given that's all you have to definition. So angle by 6. You can't take Q as the angle. Because it's a plus 10. Because it has 2 angles.
So what did you
Okay.
put RQP and what did you put to say?
If it's Q or it's over to QS, that's what you need. That's 2 sides and 1 and 2 angles.
I would like you to try to, yeah. No, but there's another reason. So first of all, you can't say Q is
Oh, yeah,
is Q because way back first week of school I told you that if an angle has more, if a letter is at more than one angle, you can't just use a single letter. You have to use the 3-letter notation. Okay, but you have the right idea, but you can't say that. No, it's not reflexive.
Oh.
Reflexive means it's congruent to itself. I'm going to put another minute on the clock because I have a couple people that were trying to work through one particular part. If you already finished, I apologize. Please be patient. And please feel free to discuss your proof with your teammates to see how you did. So we didn't finish the picture. So we already got that's one piece. So what's the second piece?
How would you write
Because QP is bisecting angle.
I'd say that's the side, and angle on another side. What's, so we've got one piece of it. This side is common.
Yeah, but you have to prove RQP converts to SQP.
What would jump out at you?
And so then that's the definition of angle bisecting. No. I don't want.
You're on your way. All right. So, for those who unfortunately didn't get to finish, I do need to move on, so I apologize. Hopefully you will get something out of this. So let's talk about the chain of logic. How many pieces of evidence do we need to use SAS? Sebastian? 3. First piece of evidence, Sebastian, what is it? I'm sorry? You didn't use side angle side? Okay, so we'll come back to you. First piece of evidence, Jada? Which is? Okay, so now when I say piece of evidence, I'm referring to the side, the angle, and the side. So if we're trying to use side angle side, and I say we need 3 pieces of evidence, I need the side, the angle, and the other side. This will lead us to a piece of evidence, but that's not the piece of evidence. Okay? It's like someone telling you that you saw the murder weapon in the closet over there, but you didn't go to the closet to look. So that's going to lead us to the piece of evidence, but that's not the evidence itself. There is a very clear piece of evidence. There is a crime scene piece of evidence, Maria. What's the crime scene piece of evidence?
QR is congruent to QX.
Yeah, so this is the crime scene piece of evidence. It's given to us right here. So one piece of evidence is done. I know Alicia knows the second piece of evidence because she said it already in the other example that we did. What's the second piece of evidence? Yeah, QP is congruent to itself. I think this threw off a lot of you. This is congruent to itself, so we've got the side, we've got the other side, but now here's the question. What angle must we use now? What angle must we use, Fung? QRP would be this angle down here. And that would be that angle here, but that's not side angle side. Because it has to be the angle that's in between these two sides. So unfortunately, that will not work. That's why I emphasize the included angle. So what's the included angle? This is important, guys. You got to be able to find the included angle. Kayla? RQP, we need to show is congruent to SQP. That's the third piece of evidence. That's this right here. So there's something here that helps us, and I already gave you a clue. What leads us to that? What leads us to this being congruent? Nobody was able to figure that part out? Michaela? An angle bisector, exactly. This, bisecting this whole angle, tells you that that is congruent to that. That's the third piece of evidence. And so when you put that all together, you get this proof. Excuse me. So I put the given separately. You could have grouped it together. But here was the key. This was the one that you had to be an investigator for. This one right here is what separates the first-year detectives from the fifth-year detectives. First-year detectives don't know how to find that. Fifth-year detectives know how to search through the pieces of information to find what they need. Everyone should have been able to figure out this piece of evidence and this piece of evidence. But you had that third one. Chris?
You could also use the definition of grade to prove that grade is congruent to itself.
Yes, you could have said Ray QP is congruent to itself as well.
Aren't all rays congruent to each other?
Yes, because they're going on and on forever. The thing that I'm not sure about is that I would be inclined to say you would want to show that this segment was congruent to itself because we're trying to prove the triangles. This is not part of the triangle. So I think you would ideally want it to be in this form, but I don't blame you for putting the form that you put. Okay?
But I use definition of rays.
Because they're all congruent to each other? Okay, I can deal with that. So any comments, questions on checkpoint number 1? Yeah, I don't think side, side, side works.
Because I looked at the angle and I thought it was the angle RPS or RPS.
Okay. Okay. Well, that's reasonable if you just made a reading error, but I don't think there's any way to prove that this is congruent to that. Now we know that they're congruent because we proved the triangles are congruent. Now we can say that that's congruent to that. But before we knew that the triangles were congruent, I don't think there was any way to do that. Sebastian, did you find a way to show that those two were congruent? Okay. All right. So now, hypotenuse leg. First of all, hypotenuse leg has some vocabulary in it. Hypotenuse, you have to know which side is the hypotenuse. The hypotenuse is the side opposite the right angle of the right triangle. So you have to know that. A leg is the other two sides are called the legs. Okay? So just to make sure we're all on the same page, hypotenuse, leg, leg. So you have to know that. Yes, Dalton. I'm sorry, hold on. Say it again. Yes. For you to be able to use hypotenuse leg, you have to show that the triangle is a right triangle. Maria helped us with that before. I talked about the fact that SSS and SAS both had 3 letters, and you need 3 pieces of evidence, and that maybe you would look at HL and think you only needed 2, but then Maria made us remember we actually need 3. So, we have to find the 3 pieces of evidence. So before we do the proof, let's talk about chain of logic. And so to help myself and to help you, what I did was take this complex picture and use my creativity and my brain to try and make it into a picture that made more sense to me. So this I pulled out, and this is now X, Y, Z. And now if I pull this triangle out, put it over here, and I didn't leave myself enough room. And so now that is W, Z, Y. So maybe that would help. Maybe you could even take it a step further and flip the triangle around so that they were both facing the same direction. So you can match things up a little bit better. It's all up to what you can handle. But now we're given some information. We're given that WY is congruent to XZ. So we are told this. And that takes care of piece of evidence number 1, H. We need 2 other pieces of evidence. We need the leg congruent to the leg in the other triangle, and we need to show that they are both right triangles. Anyone have an idea on any of them? On either piece of evidence? What do you got, Brandon? Yeah, if you notice, the original picture is what tells you that ZY is congruent to itself because of the reflexive property. So we've got the second piece of evidence, the L. But now we need that elusive third piece of evidence. Now we have to take our investigative abilities up a notch. So what can we do to find that third piece of evidence that Maria pointed out earlier? We have to prove that these 2 are right triangles. We have to prove it. How can we do it? Ania? Definition of perpendicular segments or lines. Very good. This is the information that leads to the evidence. WZ is perpendicular to ZY, and so by the definition of perpendicular lines, that shows that this is a 90-degree angle, which then proves that it's a right triangle. Applying the same logic to the other triangle, XY is perpendicular to ZY. That proves that this is a 90-degree angle because of the definition of perpendicular angles. And then that proves that those are right triangles. So now we have our 3 pieces of evidence, and so we can conclude. Okay? Dalton and Brian, and then we'll go ahead and write it out. What's that? No, we can lump them together. This one and that one, don't they have to be parallel lines? I'd have to look back. I don't know if we can. But maybe. You might be right. Chris? Let's see. Can we use side, side, side? That's congruent to that. That's congruent to that. I don't know because we don't have evidence to say that xy is congruent to wz. Do you have evidence somewhere? If you find evidence, then you can absolutely use it. All right, so let's go ahead and start laying out the proof. So statement number one, let's lump all the given stuff together. We've got wy, it's congruent to xz, and we've got the two perpendicular statements. So that's one piece of evidence right there. That's done. So I would lump together the two 90-degree angles into one statement just for efficiency. So we could say measure of angle WZY is 90 degrees, and we can also say that the measure of XYZ is 90 degrees because of Ania's conclusion that, or her deduction that that is the definition of perp lines. Now, you do have to go a step further. Remember that the proof has to be written for an idiot. So you have to say, because the idiot doesn't know that just because this is 90 degrees that means that that's a right triangle. So you have to say it. So you have to say triangle WZY is a right triangle. And you need to say that triangle XYZ and that's from the definition of a right triangle. So that's piece of evidence number two. Piece of evidence number one was way up here. We had to build to piece of evidence number two, right there. Now we need the third piece of evidence, which was the super easy one that Brandon helped us with. Brandon, what was that third piece of evidence?
ZY is congruent to ZY.
Yeah. ZY is congruent to itself because of the reflexive property. And so we've got our third piece of evidence, and now we can make the conclusion. We have now proven the triangles are congruent. Anyone have any concerns about that? Any concerns or any issues? And again, you notice I highlighted the 3 pieces of evidence. I'm trying to help you develop the ability to focus in on what you're looking for rather than getting lost in all the details and all the information. Okay? Any questions? All right, let's see how you do on your own. So I am looking for a formal proof, but the given statements are not really given, written out. They're just there for you in the diagram. I would highly recommend drawing the diagram and maybe even drawing it in a different way to help yourself. And you got 5 minutes on the clock. Given. So just to be clear, anything that you pull directly from the picture, you can just write given. So if you want to say that BCD, the measure of angle BCD is 90 degrees, you can say it's given. Okay, I'm a little low on time. Again, that's my fault, not yours, but just because of that, let me reveal my proof and then give you an opportunity to, gauge whether or not yours is correct. So, I made a mistake. Clearly that's a mistake. So I apologize for that. I copied and pasted from a previous one and I didn't change the letters, so I'm sorry. So that's should be CBA and BCD. So I'm sorry about that. So it's CBA and BCD are 90 degrees. And from there, you can say that they're right triangles. And so the pieces of evidence to use HL congruence, one second, is one piece of evidence, second piece of evidence, third piece of evidence, and now you can use HL. Okay? Chris and then Anita. Let me see. ABC would have to be DCB. So yes, I have those letters in the wrong order as well. So I apologize. This has to be DCB.
Change the ABC.
Or I could change the ABC. Yeah, either way. But this has to be C. That has to be B. So thank you for pointing that out. He's absolutely correct. Anita? Well, I was hoping you would. What did you do? Side angle side. So we have this side is congruent to this one. We have this congruent to itself, which means you would have to prove this congruent to that. How did you prove that? But that's not side angle side because it's not the included angle. It has to be the angle that's in between the two sides. Okay, that's the difference. Okay? All right. So, guys, I appreciate that you're anxious to go, but I didn't wrap up yet. So draw a line across your paper. Your homework is going to sound like it's a lot, but it's really not because a whole bunch of the questions are simple little kind of just give a piece of information kind of questions. On page 241, you're going to do numbers 3 through 17, 20 to 22, 25 to 27. And then you're going to do 3 different proofs. They're each worth 4 points. So you're using the 4-point rubric. You guys are lucky though. You've got a day off tomorrow. Shouldn't be an issue. But it will work out to 33 points total for the homework assignment. Then I would like you to either do the at-home tutor for lesson 4.6 or read the section. And you will have another quiz soon, but I got to figure out timing. Okay?